Today, what I want to talk about is how to test a convenience receptacle, right? Now, this is a little fluke, you know, tester right here. It's got the three lights on it. Everyone knows about the three lights that you're using right here. You got one light, another light, and they should light up like this, right? In that little pattern. And it's pretty easy stuff. Most tracers are going to be like this in some fashion. Here's an example of a Klein, and then here's another example. And you can see that this one's got a couple more options down there. This one's intended to be used with the little toner, and we'll come back to this one in a second. But I want to take a look at this fluke one first, and I want to talk about what it's actually doing. Well, I want to talk about here is if you didn't have one of these, how would you make sure that the cables are routed right? Like, how would you know that your convenience receptacle is wired properly? Because I see it on switchgear all the time where the hots and the neutrals are switched, right? Or something else. It's just, it gets crazy. So I want to talk about how do you discern that with a multimeter? Because I don't have one of these in my toolkit. I just use a multimeter. So how can you figure that out? Well, let this thing give you the answers, right? It says right here, this is the correct sequence. So you want this to guide you along, right? So we want the first two right ones to be lit and the left one to not be lit. Now, if they're lit, that means that they're an LED that has power applied, right? It has voltage applied. So we're talking about two terminals that have voltage across them, right? So how can we do that? Well, let's go ahead and look at the next one below. It says open ground. Well, if it's an open ground, it's not going to light, right? Which means that this terminal right here has to be ground connected, because if the ground is open, then it's not going to light up. So we have a ground right here. And if it's going to light up on a normal condition, the other terminal has to be hot, right? And then we have this next one below, it's an open neutral, right? So that means that this has to be a neutral and the other terminals are hot, because if you want it to light up under a normal condition, like the top one right here, then that's how it has to be. Now the last one, this last third light right here, is a little less intuitive, and it only lights up when the hot and the neutral are reversed or the ground and the neutral are reversed. Well, if that's the situation, then that means that the wires that you're normally designating as ground and neutral, one of them has been switched with hot. And so if the ground and the neutral are both at the same potential, then that means that now you have potential between that other ground or neutral and that now hot wire. So that means that these two right here are going to be the neutral and the ground terminals, right? And that's how you test this guy. So if you didn't have one of these bad boys, all you have to do is just go right up to your outlet and check from neutral to ground, and you should have 0 volts. And you should check from high to or hot to neutral, and you should have 120 or whatever your nominal voltage is. And then high to ground, I'm sorry, hot to ground, and you should have 120 or whatever your nominal voltage is, right? So that's how you check these things. Now, there are some other features here, and I also want to talk a little bit about what I said right here, neutral to ground voltage. Now, if you go up to any running live circuit, the neutral to ground voltage usually is not 0. Now, I'm going to give you a little nugget of knowledge here if you don't know this, but the neutral to ground voltage is not 0 for a very good reason, right? Our neutral is our normally current carrying conductor, and so any current that flows on the neutral is current times the resistance of that wire. All copper has a resistance, and so there's a voltage drop on that neutral. And because there's a small little voltage drop, even if it's half a volt, there is a half a volt difference between neutral and ground. So how can you tell which wire is truly the ground wire? Well, whichever one has the highest voltage to the hot, right? And so that's a little trick that you might be able to use yourself. But let's go down here and look at something else. So on this GFCI tester, we have additionally, and it might be a little hard to see, but they've got some other light scenarios here. Now we've seen this one, we've seen, actually I'll just cross right through it all together. I'll just say we've seen this one. Actually, we'll do this one, this one, this one, this one, this one, and we saw this one, right? So that's 1, 2, 3, 4, 5, 6. There's two more here that weren't listed on that fluke. So what are they? Well, this one right here is just GFCI testing in progress. Who cares? This middle one right here, though, it says hot on neutral with hot open, right? Well, let's go back to our other one and think about that. Hot on neutral with hot open. So here we are back on the other one, hot on neutral with hot open. Well, really, it could be hot on neutral with hot open or hot on ground with ground open, right? We don't know which one it is. Either one of those technically would suffice and allow this last light right here to light up. Okay, so I feel like that was kind of a misnomer a little bit. Not picking on them, just pointing it out. A couple more things I want to point out. So here I have a GFCI circuit, and this is what I've seen, right? I've seen these hots and neutrals switched, right? I've seen these neutrals and grounds switched. I mean, it just gets absolutely ridiculous sometimes. So what I want to identify for some people right here is which one is the hot pin? Well, safety minding. Think about this. If you were a safety minded person, which one would you make hot? The skinniest blade out of the two. That means I have less of a chance of touching the hot pin. So the smaller blade out of these two ports right here is your hot pin. Okay. And we're talking about US nominal, the 120-volt convenience receptacles. That's what we're talking about here. Nothing else, no other countries or anything. Just let's stick to the US right now. Our ground pin, right, is a non-current carrying conductor. That's how it's supposed to be defined. It is a non-current carrying conductor. It only carries current if there is a fault present, a ground fault. That means that normally it is a non-current carrying conductor. Our neutral and our hot are current carrying conductors. This wire and this wire. These are normally current carrying conductors, and because of that, they have voltage drops on those conductors. So how would you test this GFCI? All we're looking for with a GFCI is that current is flowing on this ground pin. And it's usually in the milliamps, 50 milliamps, 200 milliamps. It's very low. Some of them could be as much as 5 milliamps. So what happens if you push this button and it doesn't trip, right? If it doesn't trip, you've got a problem with that receptacle, okay? But a good check to do if you were to go ahead and use like a light bulb, and you can make one of these switches with just yourself if you really want to. All you have to do is get a plug with a switch on it, and you switch your neutral and your ground wire. And if you just have like an LED light bulb or some other small load light bulb, as soon as you turn that switch on, the current's going to try to flow back through this ground pin, and it should trip your GFCI. Right? So you don't necessarily need one of these. You can test it relatively easy. I don't recommend you go in there like some YouTube videos do and just take your fingers with a piece of wire and throw it in the GFCI plug. Probably don't recommend that. I would just buy one of these if you're going to act like that. So, but these things definitely do have their purpose. I just want to make sure that you understand what do these lights really mean? How can you test this with a normal multimeter? You absolutely can. If you're going to test it with a normal multimeter, you would want to make sure that your hot is on in neutral have voltage, your hot and ground have voltage, and your neutral to ground have zero voltage. That's how you test it. It's exactly what this thing's going to be checking every time you plug this thing in. Okay, so hopefully that helps someone. If you have any questions, throw them down in the comments, and I'd love to hear y'all's feedback. Thank you.